my screen and let me just bring up the slides. Okay. Now this is actually a hack on I'll try to turn off my camera to conserve bandwidth. It's a hack on this BitTorrent client. Now, if you remember, way back in the early 2000 plus, okay, so this BitTorrent just came out, and during that time, of course, the internet is actually quite slow, right? So this has been used to share files, and of course, we call them unregulated contents. But what I think BitTorrent actually achieved is that it is able to create an internet that bypass the DNS system. Now, that is actually a very important development, which very few people take advantage of. Okay. Now, so if you can look at this slide, so what happened is that BitTorrent is only used for file sharing. Now, what we want to do is that we are actually creating a fourth shell inside this BitTorrent, so that it can achieve literally all the functions as a full-fledged server. Now, so obviously the green color DNS cloud server is all this the web server that we have. So basically the architecture of the internet today is something without the bottom right, okay, without this. Okay. Now, so this is the future that we propose. Right. So let's jump on to this video I want to share with you, so you have a clue of what I'm talking about. Now, please let me know, to stop me if there's anything not clear or the signal's not good. All right. Now, so this screen actually shows two BitTorrent client. All right. That are interacting with each other. Now, on the left-hand side, this one is actually I'm actually hosting it through any remote desktop, so I can capture both client together, right? Now, so you can see that they are sending on this one on the left hand side is sending the a sort of a forth command. All right, this is a modified forth. I call it forth script. Okay. Now I'll explain it in detail later if the texts are too small. So just to give you an idea that we can actually send a command from a text chat, which return JSON string object. Now, JSON string object, of course, if you are working in web programming, then you know that this is the foundation of all database function calls, right? So basically, yeah, I'll share the YouTube link later, okay? So you can see that. Now, this is I hope you can see that it's is the resolution clear enough that you can see the text? Is it eligible? I mean, is it legible? 1129. Can you see that the time? I didn't expect this. Anyone? Hello?
It is visible. It's not terribly big, but it's barely visible.
Okay, yeah. Yeah, you can actually download the YouTube later, but just to show you, I'm actually being able to send this from the one side to the next. Okay. Okay, now let's jump straight to the coding part. All right, since we are all fourth programmers here. Okay. Okay, so how this thing works is that, okay, I'll just show you inside the Java editor, right? Okay, so this is the file that I modified, and basically what I did was that actually I just in fact I started by copying a reverse Polish calculator program. Okay, now so anyone familiar with Java, or you know that this is just to split the input, right, which is space delimited string into tokens. Now, so this is basically a stack machine implemented in Java. Now, if you just look at the top part, this is just a traditional standard reverse Polish calculator. Now, of course, what is interesting is that I was able to add the fourth style kind of programming into it. Okay, for example, all right, let's go back to this screen here. All right. Now, if you can see it here, let me see if I can get the, all right, now I think this is clearer here, although there are just a bunch of commands. Okay. Right. Now, if you can see this is actually a very long string of tokens, like starting JO, dub, and so on and so on. Now, what I wanted to show you is this HM. All right. Now, HM is actually mapping to a Java structure to create a hash map. Okay. So basically, I'm actually creating a stack machine within Java, okay, to create a hash map. And as you can see, this command here, the next one is AB put. Now, what it does is that it creates a key with a key A with a value B, and then the next one, CD put, create a key D with a value C. And then the next one is JK put, it creates a key K with a value J. Now, so in the end, you can see that this is the resulting JSON string. Okay, A, B, K, J, D, C, and M. Now, this is the result 2915. Now, of course, this is a trivial sort of example. But the point I want to make is that we can basically add in a lot of the Java functions in it, all right, so that you can just extend this functionality of the stack machine to squeeze the whole, all the Java functions inside this inside the stack machine, right? So basically, the aim is to achieve a fully functional web page web server, okay, within this BitTorrent client. Okay. Now, so that is actually the first part of my presentation. Before I carry on, any questions on this? Because the next part I'm going to explain a bit on the hash code, which we will be sort of something related to this as well. Any
Liang?
question on the first? Yes.
Yeah, Liang, a quick question. The goal is to be anonymous by using this. How does it help?
Okay, right. Now, okay, I'm just showing you the actual screen of this the BitTorrent, okay, chat. Now it's all in black color, so I'm sorry you can't really see it clearly. Now the advantage of using BitTorrent is that, right, you do not need to register for a DNS server. Now, of course, you can encrypt all the messages. Now, I have not gone through all the code to check that all the messages are encrypted. But of course, then, since the source code is available, we can actually encrypt all the messages so that we make sure it is anonymous, if that's your question.
Yeah, thanks. And another quick question, why do you have to use the Java layer? There's no way to bypass the Java layer?
Oh, no. Okay. Why do we have to use Java layer? Now, the reason why we use Java layer is because, okay, just come back to this. If you can look at this on the bottom right here, you see my red cursor here. You see that there are 220,000 users at any one time. That means this system, right, is actually connected to over 200,000 computers around the whole world. Now, I'm not sure whether this is only for this Java BitTorrent. Now, BitTorrent is a protocol and it has been implemented in many different other languages like Python, C++, and so on. But of course, we can verify whether this is all the user or just a bit link by looking at the code. So basically, it's actually a huge user base. Now, so what we are trying to do is that the existing program that you are seeing now, all right, this is a chat part. The original part is actually only for file sharing. It doesn't have any other function except just for file sharing. Now, of course, this is actually not active, right? Usually it is actually used for sharing files, something like that. Okay, and now if you just go onto internet and just do a quick Google, then you can actually see lots of example on what kind of files are being transferred. And it's estimated that I think about 5% of all internet traffic are based on BitTorrent. So it's actually a huge part of the whole internet. I hope that answers your question.
Yes. So we are just using Java just because we have something available, the tool.
Yeah, exactly. This Java code base is over 20 years old. I think the earliest code was written in 2003.
Okay, but technically, somebody could write a fourth dialect as long as it follows the protocol.
Yes, exactly. Yeah, I mean, we can explore, this question on how to write a fourth dialect, because later I will show you my implementation of this fourth script using other languages like Python, PHP, and JavaScript, and so on.
Okay, makes sense. Thanks.
All right. Yeah, just a quick check. Kevin, how many minutes do I have left?
Oh, I think another 15 or 20 would be fine.
Okay, another 15 minutes. All right, good. Thank you very much. All right, now let's move on to the next part of this video. Okay.
Use the prefix Omni star as Omni, meaning all or.
Okay, the next part I wanted to show you is actually right, something like this. Now, this is actually a very simple client, a web client, which has a login using RSA, okay, RSA encryption. So you see, what we do here is that we created a system for login using hashes. Okay, so for example, these are the hashes, and it does not use ordinary email or phone number present here. What I want to show is actually written in JavaScript, okay, and it is something like we say earlier, a fourth dialect, okay. Now, so for example, this is the initialization file, okay. So you can see that okay. Now let's start from here. So if you look at this line here, okay, this one, do sign IM PBK and so on. These are all RSA encryption functions originally written in JavaScript. So I turned that into a fourth kind of dialect, all right? And as a result, it's able to create a chat system for that. And beside this, there is also implementation in C++, okay, as well as Python, right? Okay. The next point is about how we actually link this all up together. Okay, now this is what we call the OmniHash system. Now, of course, if you look at the literature, hash is simply a very large integer. And what is interesting is that the hash of a series of hashes is also a hash. So this is called the automorphic property of the integer. Now, so I just want to demonstrate here, you know, if you key in, if you have a text, now this text could be a program source code or even a human readable contract, okay? Now you can convert that into a hash. Now, if you notice that if I just delete, let's say, one word, right, the outcome is going to be totally different, all right? Okay, and then what I do here next is that this is called the triplets. Triplets means that the contract hash plus the signing parties. So these three hashes will generate the root hash. Okay. Now the reason I want to show you this one is because if you look at you know how these hashes are being organized, they actually look very much like fourth word definition. All right. So I think in a mathematical sense, these are quite sort of kind of related, but of course we don't have time to explore that today, except just to show you that this is something possible. Okay. All right. So now coming back to this slide here. Okay. Now, what is actually the plan for doing all this? Okay, you see, there is something, you know, that I'm not sure whether you have been paying attention. That is this is actually the revenues for the top 5 tech company. Now, I think it's a coincidence that they have the initial of MNAGA, right? So it's nothing political. So it's just you know, coincidence. Anyway, what I wanted to emphasize here is that they are actually making $1.6 trillion in 2023. Okay, and what we are hoping to do is that if we can create a decentralized cloud and metaverse system, all right, based on the architecture that I have shown you earlier, right? Perhaps, all right. So now, coming back to this diagram. So this is actually what is making you know, $1.6 trillion in 2023. Now, and in fact, a lot of these big tech company and even a smaller tech company, they are actually making use of a free software source code, all right, to run their businesses. Now, so what happened is that there is actually a very important concept that
We use the prefix Omni star.
there is actually a very important concept that has been overlooked in in free software. Okay, that is what we call the problem of disclosure and royalty. Okay, now disclosure means the right to share code and review code, and royalty means that the permission given to to use the code. And these two aspects of the source code has not been distinguished in the existing free software license. Okay, so what we hope to achieve is that by using this hash contract, okay, we are able to use the hash to track the royalties. Okay, that means the usage of this code. Okay, and so that also we can claim the money from these big software companies. Now, besides that, of course, there's another way for using this hash code, that is to use that as a digital asset to motivate groups of free software programmers to work together to produce better software. Okay, so I think that's the end of my presentation. Thank you very much.
So basically, if the goal, if I understand it correctly, Liang, you would be having a meter on every time somebody uses your function.
Yes, that's actually the goal. Yes, that's correct. Now, in fact, I want to say that actually that is actually achievable even today, but this has not been sort of popularized because nobody seems to care to tell free software programmers that we have the right to claim royalties from people for using our code. So that's something that I hope to maybe make people aware. Thank you. Yeah. Kevin, are you saying something? Your mic is muted. Any more questions?
That's pretty exciting, Liang. The whole project.
Yeah, I'll share the link for the video in the chat area in a minute, and also my email address. If anyone would like to collaborate, you see that one of the way I see this thing may help a younger programmer is that you see it provides a fourth dialect based on multiple different programming languages, so it's going to be easy for anyone to pick up fourth, I hope, and to promote this fourth programming language using this method. Yeah, thank you.
All right, I think Kevin has stepped away. Are there any additional questions, or we could start? Bill, was the idea that you were gonna I should present your recording, or what? I see you're here.
His mic is muted. Not sure he's talking to us.
I think he can't. He does not have his headphones on, so I suspect he can't hear it.
Can't hear us. Yeah. All right.
No worries.
So
I think the next item on the agenda is the video. So let me go ahead and Bill, unless you're going to be presenting live, let me double check. But I think I have a pre-recorded video for Bill, which I'll present. 1 second. Okay. Oops.